Today we're going to carry on with the radioactivity topic, and this will be our second video in the series. Last time we looked at different models that we have for the atom, and we came across J.J. Thomson's plum pudding model and Rutherford's nuclear model, and now we're going to look at the experiment that Rutherford did to come up with this model for the atom. So in 1909, Ernest Rutherford designed an experiment to test the plum pudding model, and this became known as the gold foil experiment. In the experiment, he fired tiny positive charges called alpha particles at a very thin sheet of gold, which was suspended in a vacuum, and then he used a detector to see what happens to these particles when they pass through the gold atoms. Now, if Thomson was right, the alpha particles would just pass straight through the gold atoms unaffected. This is because, according to the plum pudding model, the atom is a big ball of positive charge, which is filled with these small negative electrons. So at any point inside the atom, the overall charge is zero, the positive charge and the negative electrons cancel each other out. So the alpha particles have no reason to be affected by the gold atoms, and they'll just pass straight through. What they saw during this experiment was a lot of the particles pass through the gold unaffected. Great, exactly what we expected. However, we did see a small percentage of alpha particles scatter at small angles. We didn't expect that. And we saw an even smaller percentage of alpha particles bounce straight back to the alpha source. So they were reflected at a 180-degree angle. This means the plum pudding model must be wrong. So how can we explain this then? Well, for this to happen, there needs to be a small concentration of charge in the middle of the atom. This means all the positive charge in the atom is located in a small space right at the centre of the atom, rather than being spread over all parts of the atom. So this led Rutherford to the conclusion that the atom has a very small positive charge in the middle, and we call this the nucleus. But remember, most of the alpha particles did pass through the atom unaffected. So that tells us that the atom is also mostly empty space. So the gold foil experiment shows us that the atom has a small positive central nucleus and it is mostly empty space. And we call this model the nuclear model. This is what Rutherford came up with, the nuclear model of the atom.